So on number 1, it says, you got to understand what it says, right? It says 2 times x equals 8. Now you could think of this logically. 2 times a number equals 8. What's that number going to be? 2 times what is 8? 4. The answer is 4, right? But of course, we want to show our work. We don't just want to say the answer. So how do you get rid of something? You do the opposite. The opposite of multiplying by 2 is dividing by 2. So you put a division bar and 2 right there. Now this is going to be off balance right now. If you divide by 2, it's going to get lighter. So you're going to have to divide the other side by 2 as well to maintain the balance. So the 2's cancel. What do we have left? Well, the x, this x, it just comes down. The equal sign comes down. And 8 divided by 2 is 4. So there's your answer, x equals 4. Okay? What math is going on right here? It says x, what?
Negative.
Minus 2. How do you get rid of a minus 2?
You add it.
You do the opposite, which is add it. So plus 2 here,
They cancel out.
and that's going to be off balance. If you add 2 to the left side of the equal sign, it's going to be heavy on the left side until you add 2 to the right side, and then it'll get back to being balanced, right? So we now have the minus 2 with the plus 2 that cancel out. The x is what's left over. The equal sign comes down, and 6 plus 2 is 8. There's your answer, x equals 8. Number 3.
Multiply.
Again, let's understand what this says. It says a number divided by negative 3 equals 6. Now think about that, Ivan. If you say something logically like a number divided by negative 3 equals positive 6, then you know that this has to be negative. So what negative number divided by negative 3 will give you a positive 6? Negative what?
2.
Negative 2 divided by negative 3 gives you a positive 6? Negative 18 divided by negative 3 will give you a positive 6. Now let's say you weren't able to get that answer logically. Either way, even if you did get it logically, I want to see the work. The way to get rid of a division of negative 3 is to do the opposite of dividing, which is multiplying by that same negative 3 value. So when you have a negative 3 up on top and a negative 3 on the bottom, that'll cancel out. But then again, what you do to one side, you must do to the other side. So what do we have left on the left side? We have the x. Let me put the x. We have the equal sign that comes down. And then the 6 times negative 3, it's negative 18. There's my answer. If you ever get an answer and you want to double check it, just take that negative 18, put it up here instead of x. Negative 18 divided by negative 3, it really does equal positive 6. Number 4, right here we have 5 times a number equals negative 2. The way to get rid of that multiplication of 5 is to do the opposite. And the opposite of multiplying by 5 is dividing by 5. Notice I'm not changing the sign. I'm not making it a negative 5. It's just if you're multiplying by 5 up here, you're going to be dividing by that same exact 5 down there. That way the 5's cancel. But then again, what you do to one side, you must do to the other. Now, could you actually divide negative 2 by 5? No. So we're just going to leave it like that. Your answer is x equals negative 2 divided by 5, negative 2/5. It's okay to get fractions as answers. This last one is one of the easiest questions that they could ask you because you want to get x by itself. That's the whole goal of solving any equation, to get x by itself. And there's a negative sign right here. You don't want it to be negative. You want it to be positive. So if you multiply both sides by negative 1, you'll have a positive x. So you could put times negative 1 times negative 1 to show your work, but the bottom line, that'll change it to a positive x, and that'll change that 3/4 to a negative 3/4. And there's your answer. Let's move on to something more fun. Fractions. Yay. Now, a lot of people get confused right here. They get freaked out because of the fraction, but wouldn't it be ridiculously easy if this did not say 2/3 x, if it just said 2x? That would be easy, right? Because 2x really means 2 times x, and to get rid of the multiplication of 2, you would divide by 2. So it would be nice if we had 2x, but we don't have 2x. We have 2/3 x. Okay, so I would like to get rid of this division bar and this 3. So I don't want this divided by 3. How do I get rid of something? Do the opposite. What's the opposite of dividing by 3? Multiplying by 3. So put a times 3 right there. But now it's going to be off balance until I do what? Multiply this side by 3, and then it gets back to being balanced, right? So I multiply by 3 because it'll cancel out. 3 divided by 3 is 1. And I have no more fraction. I now have the beautiful 2x equals 4 times 3, which is 12. My next step will be to get rid of what I see here. It says 2 times x equals 12. We already know the answer is going to be 6, right? 2 times what number is 12? 2 times 6 is 12. Answer 6, but let's show our work anyway. To get rid of the multiplication of 2, I am going to do the opposite of multiplying by 2, which is dividing by 2. And that's going to be off balance until I do it to the other side to maintain the balance. So the 2's cancel. My answer is x equals 6. 12 divided by 2 is 6. Number 7. There's many different ways of doing number 7. What do you guys suggest? Adding 5 would work great. Why? Because plus 5 here, that'll cancel out, and plus 5 over there gives me a nice, beautiful answer. What is that answer? What's negative 2 plus 5? 3. So I could rewrite what I have now, negative 3/4 x, bring down the equal sign, and we said that negative 2 plus 5 is 3. So there's my new equation, and now I could get rid of the fraction, right? How do I get rid of this fraction? Multiply by the denominator 4. So put a dot somewhere and put a 4 somewhere up there. And what you do to one side, you must do to the other to maintain the balance. Now the 4 up on top and the 4 on the bottom will cancel out. What's left over on the left side?
3x.
Don't forget about the negative though. Negative 3x equals 3 times 4 is 12. For your final step right here, you have negative 3 times x. So how do we get rid of that multiplication of negative 3? Divide by negative 3. And what you do to one side, you do to the other side to maintain the balance. So the negative 3's cancel. And over here, we end up with just the x left over. The equal sign comes down. And 12 divided by negative 3 is negative 4. You could use a calculator if you need it. There's your answer for number 7. Could you have done it differently? Yes. Like, for example, if you wanted to, you could have said, I want to get rid of the fraction first, but I don't recommend that because if you multiply by 4 here, you'd also have to multiply this 5 by 4 and you get a 20, and this negative 2 by 4 and get a negative 8. So it'd make everything bigger. So you could get rid of the fraction first, or you could do what we did right here, getting rid of that 5 and then getting rid of the fraction. Now number 9, it's kind of weird here. We have 2 fractions that we're dealing with. So I want to show you this same problem 2 different ways. So one option is you see fractions, you don't like fractions, let's get rid of fractions. So which one do you want to get rid of, Destiny? Which fraction? Pick a fraction. 1/2 or 2/3, doesn't matter. All right, 2/3. She wants to get rid of 2/3, let's get rid of 2/3. How could you get rid of the fraction 2/3? By multiplying everything by what?
3.
By 3. So if you put it times 3, that'll cancel out. But you can't just do it to one little piece of the equation. You have to do it to the whole thing, right? So you have to multiply this by 3 also and this by 3 also. That way you maintain the balance. Everything multiplied by 3. So right here, will this 3 cancel with that too? No. So let me just rewrite what I have. I have a 3 over 2 with an x. How did I get that? Because 3 times 1 is 3, and the 2's on the bottom. And then now we have the plus, and we said that these 3's canceled, so I have a plus 2 left over. Plus 2 equals 12. 4 times 3 is 12. So now what would I do?
Oh, you're going to subtract 2.
Subtract 2. Okay, so let's subtract 2. Subtract 2. My new problem will read 3 over 2 with an x equals 12 take away 2 is 10. And then, now what? We're going to multiply everything by 2. This times 2 and this times 2. Now remember, this is a fraction. It's an actual number. So when you multiply by 2, the 2's cancel. You don't multiply the 3 by 2, right? Unless you wanted to multiply first, then reduce. But right here, we're actually multiplying by the denominator to cancel it out. You're going to end up with a 3x equals 10 times 2 is 20. So my final step will be what? Divide by 3. And x equals 20 divided by 3. We can't do that. We're going to leave it. 20 over 3 is a fraction, the answer. Do you guys understand that?
Yep.
Okay, now, here's a different way of doing it. Let me actually do this. Check it out. Move that to the side. Same problem. But if you see the denominator 2 and the denominator 3, you could technically multiply by your LCD. All right? Now, what does that mean? Your least common denominator. So what would the least common denominator of 2 and 3 be? 6, right? So if I multiply everything by 6, it'll get rid of both fractions at the same time. So if I go times 6, times 6, times 6, everything by 6, it'll get rid of all fractions at the same time. Now, if I say 6 up on top divided by 2 on the bottom, well, I could reduce both of those numbers by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. So what do I have left on this first part? I have 3 with an x. 3 times 1 is 3 with an x is 3x. And over here, the 6 up on top divided by 3 on the bottom, that'll be 2. And then 2 times 2 will be 4. Or another way of doing it, if you don't like canceling, you could actually say 6 times 2 is what? And 12 divided by 3 is 4. Same thing. So it's up to you if you want to multiply first and then reduce, or if you want to reduce first and then multiply. I like reducing first and then multiply. Like I like to look at this 6 up here and this 3 down here and say, oh, 6 divided by 3 is 2. 3 divided by 3 is 1. And then I multiply 2 times 2, and that's how I get the plus 4 right there. Then you bring down the equal sign. 4 times 6 is 24. So you see how we got rid of both fractions at the same time by multiplying everything by the LCD? So that is completely up to you. Do you want to get rid of one fraction at a time, or do you want to get rid of all the fractions at the same time? It's totally up to you. There is no right way, no wrong way. It's just whatever you feel more comfortable with, all right? But anyways, if we keep solving here, minus 4, you're going to end up with 3x equals 20. And then you're going to divide both sides by 3, and you get the same answer, x equals 20 over 3. So it's totally up to you if you want to get rid of one fraction at a time or both fractions at the same time. Let's go back to the board here. Right here we have 3 fractions. So right here where we have 3 fractions. Oh wait, we skipped one. Sorry. This one's way easier. Why is that? What do I do? Fractions have the same denominator, which means I multiply everything by what?
2.
By 2. So times 2, times 2, times 2. Cancels. You end up with 1x minus 3 times 2 is 6 equals, over here the 2's cancel. What do we have left on the right side? 1. So you really have 1x minus 6 equals 1. You don't even need that 1 in front of the x. It's just x minus 6 equals 1. Add 6, add 6. You're going to end up with x equals 7. Sorry, skip that one. Let's go back to this fun one right here, number 10, where you have 3 different fractions. So the question is, do you want to get rid of one fraction at a time, or do you want to get rid of all fractions at the same time? All fractions at the same time? Okay, so it's going to take some thought. So if I wanted to get rid of the 1/2, I'd multiply everything by 2. But nothing else would cancel out, just the 1/2. Or if I wanted to get rid of the 2/3, I can multiply everything by 3, but nothing else would cancel out. If you want to get rid of all fractions at the same time, you got to look at the denominator 2, the denominator 3, and the denominator 4. Now, I would go to the biggest denominator and ask yourself, could I change the other ones to become that one? If that's the case, then multiply everything by 4. But you can't. So I would take this big denominator and multiply it by 2. 4 times 2 is 8. And 2 works with 8, but 3 does not work with 8. So 4 times 3 is 12. 12 is divisible by 2, 12 is divisible by 3, and 12 is divisible by 4. So your LCD is 12. Does that make sense? So we're going to multiply everything by 12. It'll get rid of all fractions at the same time. So the 12 divided by 2 gives you a 6. So what do we have left over right here in this first part? 6 with the x. How about over here, the 12 up on top and the 2 on the 3 on the bottom cancels out. You end up with the 4. So what do you end up with right here on this next part? Plus what? 8. Because the 4 times 2 gives you the 8. And then on the last one, the 12 up on top cancels with the 4. You end up with the 3 left. So you end up with equals what? Equals 9. So there's your problem. 6x plus 8 equals 9. You're going to subtract 8. Subtract 8. You're going to end up with 6x equals 1. Final step would be to do what? Jonathan, Cruz. How do I get rid of that 6 in front of the x? Divided by 6. Thank you, Destiny. Heavenly, sorry. They said Destiny, that's why. Heavenly, I knew that. X equals 1/6. Do you guys want to see this done a different way? No. Let's say you don't like getting rid of all fractions at the same time. Let's say it's too much, you get confused. You could get rid of one at a time, okay? Look, watch, pick a fraction. Let's get rid of one of them. 2/3. Let's multiply everything by 3, that way it cancels out. So this times 3, this times 3. Now notice right here, the 3 does not cancel with the 2, right? So you're going to actually have to multiply 3 times 1 and then put it over that denominator that didn't cancel. So 3 times 1 is 3. You're going to put it over 2. It still has an x. Now, yeah, this guy right here, it ended up canceling out. That's beautiful. You end up with the plus 2. The equal sign, again, right here, the 3 and the 4 don't cancel. So you're going to actually have to multiply 3 times 3 and get what? 9, and keep it over that 4 that didn't cancel with anything. So you're going to end up with a 9 over 4. So barely right there, we have just canceled out the 2/3. We got rid of that fraction 2/3. So we still have other fractions to get rid of. Which one should we get rid of next? Now, because 4 and 2 work with each other, if you multiply everything by 4, it'll get rid of both of them at the same time. If you get rid of this 2, it'll get rid of one of them only. So it's up to you. 9/4. What are we going to multiply everything by?
4.
Times 4, times 4, times 4. So the 4's cancel. You end up with the equals 9. The 2 times 4 is 8. So we end up with the plus 8. And right here, the 4 up on top and the 2 on the bottom, 4 divided by 2 is 2. But you still have to multiply 2 times 3, and you will get 6 with an x. Which is the same problem as we got before, right? So if you subtract 8, you'll end up with 6x equals 1. And if you divide both sides by 6, it'll be x equals 1/6, which is your final answer. Whoa. Which is the same answer that we got over here. There's only one more type of question. I'd like you guys to write this down. Let's say, let's do a number 11 here. And let's write down 2x minus, give me a number. 4 divided by, you said 5? Sure, why not? And let's say equals, give me a number. 6, I don't know. There we go. On this problem, we have one giant fraction. So we need to get rid of that one giant fraction by multiplying both sides by what?
5.
So put a times 5, a times 5. The 5's cancel. There's your problem. 2x minus 4 equals 30. And then you just solve it the way you normally would. Plus 4, plus 4. You're going to end up with 2x equals 34. And then you divide both sides by 2. And if you divide both of those by 2, you're going to get x equals 17. So that one's definitely easier than the rest. So we're going to get this worksheet right now. And we're going to do this for the rest of class. It's our classwork assignment / homework if you don't finish it. The answers will be posted on the back. But as you can see right here, we have several equations that have fractions in them. So let's just take a look at number 8. What would you do on number 8? Get rid of all the fractions. Now, how would you get rid of all the fractions? By multiplying by the LCD. Now, if you think about 3, 4, and 12, what's the least common denominator on 3, 4, and 12?
3.
Actually 12. Right? 12. Now, see, it's this simple, guys. If you were to multiply everything by 3, the 3's would cancel, but the 3 would not cancel with the 4. The 3 would be able to be reduced with the 12, but it wouldn't get rid of the 12 completely.
We'd be able to do 12 times 12 divided by 1.
But if you multiplied everything by that biggest denominator 12, if you multiply everything by that biggest denominator 12, check this out. 12, 12, 12. Yeah, the 12s completely disappear. You end up with a nice 71 on that side. And when you look at the 12 over 4, what's 12 divided by 4? It's 3. So 12 divided by 4 is 3 left over up on top. And up here we have 3k times 3. That's going to be a 9k, positive 9k. And then over here, 12 divided by 3. What's 12 divided by 3? 4. So what do we have left up on top? 4 times 2. What's 4 times 2? 8. We got rid of all fractions by multiplying everything by that biggest denominator, which happened to be the LCD 12 of 3, 4, and 12. So now we just solve it by subtracting 8. Subtracting 8, you will get 9k equals 63. Of course, you could use a calculator. Then you're going to divide by 9 on your final step. With the calculator, you should be able to see that k equals 7. And that's the answer for this hardest question on your worksheet, number 8. So let me pass this worksheet out. By the way, the answers are on the back. The work's on the back. Please finish this worksheet, understand it, because you will see questions like this on Friday's quiz.